Hey there, this is Terry again with another video. In today's video, I want to address the question of how to be a great developer. Not how to be a developer, not how to be a good developer, but how to be a great developer. Obviously, this is just going to be my opinion, but I think most of the best developers I've worked with in the past will generally agree with what I have on this list. This is not necessarily going to be an exhaustive list either. It's just some of the top points that I have thought about lately. Let's start with this one. Great developers tend to be lazy, sort of. So what do I mean by they tend to be lazy? I've worked with hardworking developers who I didn't think were all that great of developers, but they were really hardworking. By that I mean they just rolled up their sleeves and got into the code and banged out a lot of code until it was doing what it was supposed to do. But they sometimes lacked a certain mindset that I have come to associate with the greatest developers that I've worked with. That mindset is one in which they don't like to do a lot of manual work. So if there's a lot of data that needs to be processed, let's say, many great developers that I've worked with might prefer to spend, just giving an example here, might prefer to spend 10 hours writing code to automate the process of parsing through a bunch of data, though it might take 9 hours for them to manually parse that data one time. The difference here is that if they end up having to parse data of that same format again 2 months later, they'll have a program or a script that can now do it ideally in seconds rather than another 9 hours. But a lot of the so-called hardworking developers who don't appear to be lazy, it's almost like they're very much the roll up your sleeves and let's just get in there and just get this done, rather than let's hold on a minute and let's think about how we can solve this problem in an efficient way that fully utilizes our knowledge of programming and what a computer can do. So in some regard, the roll up your sleeves hardworking developer might be viewed as being a bit impatient when it comes to the other type of hard work of thinking, right? Just manually sitting down and banging out 9 hours of just typing in a lot of data or whatever it is, that the manual way of doing this contrived example that I'm giving. That's usually going to be work that doesn't require as much deep thinking. It's more like mindless, just, hey, let's just do this. You're basically a data entry person at that point. So yeah, I've worked with a few developers who know how to code, but they'd rather be feeling productive in the form of typing a lot and just getting something done rather than thinking a lot and then getting something done later, right? So I generally refer to this type of programmer, the thinking programmer, as appearing to be lazy, right? Because when you're just kind of sitting around thinking, it doesn't look like you're doing anything. And programming very much is a thinking sport, right? You do a lot of your programming in your head. Ideally, for non-trivial problems, in fact, you will spend a significant amount of your time thinking about the problem, thinking about how you're going to solve the problem in your head before you ever actually start coding anything. And hopefully, by the time you start the coding, you've really got something, right? And it's somewhat well thought out. You may have to revise it, but hopefully it's somewhat well thought out. So embrace your laziness. On the same subject of being lazy, I've noticed that a lot of the greatest programmers I've worked with, they pride themselves on memorizing keyboard shortcuts for their programming tools. By the way, if you're really new to programming and you may not be familiar with the tools, the primary tool, I guess I might say, the primary tool of a software developer in many cases will be their IDE, or integrated development environment. Think of it basically as a word processor for programming. So if you are a writer, your primary tool might be a word processor. If you are a programmer, your primary tool might be an IDE. Doesn't have to be, by the way. There are some seemingly hardcore programmers who don't want to use proper IDEs, and they just use a very basic text editor. I've known one or two. Personally, I didn't have a lot of respect for them. I'll make another video where we can go into more detail about my thoughts on that. Hopefully there aren't too many people out there who are thinking this way anymore. But anyway, yeah, so your IDE will have a lot of different keyboard shortcuts to do all kinds of things, so that you don't have to keep going up to the menu bar every time you want to do something like what we call refactoring of the code. That's basically a really fancy programming version of search and replace. Really fancy version of search and replace, though. So there are so many refactorings and so many things that you can do with modern IDEs today. And it wastes a lot of time every time you have to grab the mouse or the trackpad to go to the menu or right click on something and then search through the menus and find the thing that you want to do, versus just using the keyboard shortcut. Bam, your hands were already on the keyboard while you were typing code, and now you want to refactor something or run something or whatever. Rather than having to move your hands off the keyboard to go do something else, bam, you can just hit those keyboard shortcuts and go. I do feel a certain correlation between the level of coding prowess in a developer and to what extent they have taken the time to learn the most useful keyboard shortcuts. I'm not saying that there aren't great developers who don't use many keyboard shortcuts. I'm sure there may be, but off the top of my head, all the best developers I've ever worked with have taken the time to memorize keyboard shortcuts for the functions that they do frequently. That's all I'm saying. There just seems to be a strong correlation in my experience between so-so developers or even bad developers and their unwillingness or disinterest in taking the time to learn the tools of their craft very well. And I think that's really what I'm getting at. It's really about learning the tools of your craft. Well, it's about learning the tools of your craft, but for the best developers, I think it's about learning the tools of your craft so that you can save time, because you're impatient with wasting time, wasting time on the same actions over and over again. And while we're on the topic of IDEs and keyboard shortcuts, that will bring me to the next point, which is that a lot of the greatest developers I've worked with tend to have real opinions about stuff. They have real opinions. Many times you can ask them, the best developers, what's your favorite IDE? Bam, they know the answer to that. If they code in multiple languages, they may have an opinion about what is their favorite language or what is their preferred language for certain types of tasks. They may have a strong opinion about that. Or conversely, they may have strong opinions on why they don't like something. And these shouldn't be opinions that they feel that they're supposed to form. These should be naturally formed opinions that, they, even if they lived by themselves, if they were the only people left on earth, they'd have this opinion. Okay, so another point is intelligence. So intelligence certainly doesn't hurt. Do you have to be Einstein? No, you don't have to be Einstein to be a programmer. Especially as I said in my first video, I think my focus has been for most of my career on business programming, and a lot of business programming, a lot of it, not all, but a lot of it is pretty straightforward. And sometimes it's hard to find opportunities to really utilize your brain for the deepest kinds of problem solving, because a lot of business programming really just comes down to giving users a way to enter data and save it into a database and get it back out. So not a whole lot of opportunities there for like really awesome coding all the time, but it does come up from time to time. It absolutely does. And when it does, it helps to have a bit more intelligence. Where I see the intelligence really coming into play, or at least some of the places where I see it coming into play, are particularly when problem solving or troubleshooting, right? So we've written this code and it's not behaving as we thought it would. I see, let's say vaguely, two categories of programmers here. There's the throw everything at the wall and see what sticks kind of a coder, either when they're trying to get something to work or when they're trying to figure out why something isn't working. And then there are more methodical programmers who hopefully actually have a mental model of how the systems work, how the language works, how the tools that they're using are working, and they start to think through that model in their head of how everything works, to logically break down, okay, well, if I'm seeing this outcome here, that seems like it should be related to whatever, right? They're thinking it through and not just guessing and trying everything in the world until something sticks. That tends to be a more effective and efficient way of solving problems. I think, so I will say two things. Partially that is a function of intelligence, but it's also a function of just knowing your stuff, right? Like there, at some point you just have to actually know how things work, and you're only going to learn that by studying, which brings me to another point. There needs to be a willingness to learn. You have to be willing to keep learning. It is not enough just to learn a programming language and one framework 5 years ago, and then you never keep updating your knowledge. Programming is very much a field that is constantly evolving, and whatever was in vogue 3 years ago, I can almost guarantee you it has either morphed or it has fallen out of favor, or it's getting ready to be supplanted by two or three other things. There's always something new that you need to stay on top of in order to make sure you're solving problems efficiently today. And part of that, going back to my previous point, is just in general, like you're never going to know everything about a system or a language or a framework or whatever. So there will always be more that you could learn about that thing in all likelihood. And the more you know about these tools that you're actively using, the better equipped you can be to solve problems when they come up, and they will come up. These systems always have issues. As soon as you're writing anything that's non-trivial, and sometimes even when you are writing something that's trivial, problems can come up, and you need to have enough of a foundation of knowledge to be able to help you to solve those problems efficiently and effectively. Another point is having a strong attention to detail. Programming is a detail-oriented activity. There's syntax in programming languages. Keep in mind, I mean, we're basically trying to write instructions that a computer can understand. Computers don't really have a lot of fuzziness to them in terms of their ability to interpret what they thought we meant. Computers just today don't work that way, and programming languages definitely don't work that way. We must be fairly precise in what we're trying to say. Whether it's just putting a semicolon, remembering to put a semicolon at the end of statements that require them, or the syntax or whatever. I have worked with programmers who, in my opinion, didn't have sufficient attention to detail, and they would write code that was sometimes somewhat riddled with little errors. Now, the strange thing here is that the IDE, the integrated development environment, it will show you those errors. So I've worked with some programmers who had such a lack of attention to detail that they didn't even notice the errors that the IDE was showing them. That's not good. When I'm pairing with that kind of a programmer and they just keep on trucking and writing code and writing and writing, and there's all these glaring errors there and they're just like oblivious to them, it drives me nuts. Don't be that programmer. If that doesn't come naturally to you, then you're going to need to spend time just like scanning through looking for those errors. Me personally, I don't like errors to remain. Well, there are certain types of errors. There's warnings and then there's errors. I don't like actual errors to be in my code for more than a second. Like while I'm typing, I see those errors and I typically address them right away. I've worked with some programmers who maybe see them and they think like, oh, I'll come back to that after I finish this train of thought. I don't know. That's not me. Now, I'm not going to fault them for that as long as they actually come back like soon, really, really soon. But I like to address those things right away. Plus, in many cases, the IDE can't help you with what you're currently typing if you have errors preceding that. Because either it doesn't know what type of data you're talking about because you have a typo or whatever. So I like to address those things so that the IDE can do its job and give me suggestions or whatever. Okay, and here's another point. You need to be capable of thinking abstractly. This is really important. When you're solving problems in programming, basically the task of programming has a lot to do with hearing real world problems that we want to automate with a computer and then trying to figure out how can we translate that real world problem into instructions that a computer can understand. Typically, that's going to require us to think abstractly because I'll give you a small example. Let's just say that you are a programmer and you have to make a blackjack game. So you're going to need to translate the real world rules of the card game of blackjack or 21. You're going to need to translate that into programming concepts and structures, data structures, and things that you learned in programming. And I think the best programmers are able to do this relatively seamlessly because those data structures have actual meaning. So a deck of cards, you might have to model something that represents a card. And then to have a deck of cards, you might have some kind of programming construct that collects multiples of a thing. In this case, multiples of a card. Maybe that's a collection data structure like a list or an array or something of that set, or a set, something of that sort. So being able to translate these real world business requirements, or in this case, game requirements, into programming concepts and structures and things like that's where we start to get into the abstract thinking. To me, that is really kind of maybe the essence of real programming. There's a lot of programming that can be done, especially in business, that doesn't require that kind of abstract thinking at all. And you can get away with just rote memorization. But then there's what I like to, refer to sometimes as real programming, where you're actually having to translate some ideas or rules or requirements into a way that the computer can understand. And that's why abstract thinking is kind of important as a programmer. But as with most things, I think it can be learned, it can be taught, and it can be learned to a large extent with practice, if it does not come naturally to some. So, anyway, these have been a few of my thoughts on what it takes to be a great programmer. If you enjoyed this video and you got anything out of it, please leave some comments below. Give me some feedback. I'd love to hear what you're thinking. And please also like and subscribe, and I will see you in the next video.